Good evening to all the attendees. So today we are having this weekly webinar from the Solar Labs on the design optimization. So we'll start in around 5 minutes. We'll wait for 5 minutes more to see if there are more attendees. Please be patient. Good evening to all, and thank you for participating in this webinar. I'll be presenting this webinar from the Solar Labs. Today's topic is design optimization in the Solar Labs Design Studio. So I see there is one raised hand from Satyabrata Nayak. Please ask your query if you have any. You can give it in your Q&A section or can ask in the chat. Okay, so we have Okay, so now I'll start sharing my screen, and if you have any doubt, please post them in the Q&A session. Also, we'll have a doubt session after the webinar. So please feel free to ask all your questions. I'll now share my screen with you all. Yeah, so is my screen visible to you all now?
Yes, Satyam, it's visible.
Okay. So like first we'll draw this RCC roof and then we'll show see how we can use the features of Solar Lab to optimize our design to its best. So to draw the rooftop, I'll use the polygon tool. Okay, so right now I have created this rooftop. If I show it to in 3D, you can view in 3D. So this is how my rooftop will look like. Okay. So next part, what we come to after designing a rooftop is to know like where is it the best place to place panels on top of my roof. So for that, we have this option here called heat map. So if I refresh my heat map, my rooftop will come under color coding. So let it get, so let the system generate the heat map. So here is how your rooftop will come up in color coding. So here we can see that as these two rooftops are on a higher place compared to this one. So this is coming in green, means it is completely shadow free. There is no shadow on this rooftop. While on this rooftop, we have some yellow part which will be shadow free. Then this reddish part will have some shadow. And if you go from yellow to this blue and then purple, so it is like more shadow will be there. If you go from yellow to purple, the higher the shadow. So in this part where we have this blue purple area, so we'll have a lot of shadow here. So we can also like visualize this because there is this mountain which is at a height greater than this area. So obviously this part will have some shadow. So like this, you can optimize your places where it is best to place the panels. So I'll show you. Let me hide the heat map first. Okay. Next comes is placing the panel. So to place the panel, I'll use the fill face option for here. So after placing the panels, like Like you all know, we have some options like we can change its tilt, change its azimuth, and the table properties, orientation, mount height. So for right now, I'll use the same placement and save the design, and I'll check the solar axis of all my panels. So if I refresh the solar axis, all my panels will come under a color coding which shows me how much solar axis they are receiving, or how much direct sunlight they are receiving. So here we can see that these panels are receiving good sunlight, that is 99%. But for these panels, they are receiving lesser. So why? Because there is this mounting, so they will have some effect of the shadow from this mounting. So to optimize our sub array, now we have to go to the sub array part. We have this option here called optimize. If I click on optimize, I can move this slider to the left to remove all the panels which will be under the effect of shadow. Or second thing is I can just select the sub array. Let's say I want a sub array of 125 kilowatt. I can enter that, press enter. It will select all the panels, best panels based on that size. Then we have a access threshold. Let's say I want all my panels to receive sunlight for at least 97% of time. So I'll just enter 97 here, press enter. It will select all the panels like that. Okay. So this is how you can optimize all the panels on an RCC rooftop. Second thing what we can do is, let's say I want the complete size. So what we can do is we also have the option here to increase the mount height, because we know this mounty is at a particular height. So if I increase the height of my panels to this mounty or higher than this mounty, then these panels will not have the shadow. So for that, we have this option here, that is the mount height. So this mounty was 3.5 meter. Let's say I place my panel exactly at 3.5 and I update these. So if I save my design now, and once again I refresh my solar axis, so now we can see the change. Right, these panels which will previously coming in red part, this reddish part, now they are coming in the green portion. So either like if you want a greater size, so you can increase the mount height, then you can check. Also, if you change the tilt, let's say right now they are at 20-degree, let's say I want them to place that 15-degree. So if I change the tilt and update, then once again if I check my solar axis, so we'll see there will be some changes. So now we can see that prior to this, these panels were coming in. These are coming like 99, but now they are 97 because the tilt is lowered. So like this, you can optimize your array to a good size where you can check the size now. So let me get back to my previous orientation. First, I'll hide this. Okay. So this is like how we can optimize our solar panels based on the sunlight they are receiving. So we can optimize using these features. Like you can set tilt to different tilts to check which is the best orientation, which is the best tilt. You can check with different mount heights. So we have this option. Then also we have one option here. So let me show you. If I go to sun simulation, let me show it to in 3D. So here we can see for this day. So today is 28/5. For any particular day, you can check it. So and for any particular time. So we can see that when we are at 9:41, there are some shadows on these panels. So like this, we can also check like which of my panels are receiving shadows. So from this, we can also check the inter row shadow if the panels are creating shadow on each other. So right now we can see that there is no effect of inter row shading. But let's say if there is some effect, let me go back to. So right now we are giving you a system. The software is AI based, so it will automatically detect the row spacing so that you don't have the inter row shadows. Let's say if I change this to manual, I give it as 0.8 and update it. So now we can see the inter row spacing is less. So now if I check it, so we'll be able to see that there will be some inter row shadows. So like this, you can also check for inter-row shadows. And if you think that you want to increase the spacing between them, so we have that option. You can just simply click it on manual. In auto, it was 1.16. So you can just simply click it manual and can increase the row spacing. So like this is how you can optimize your part. So is there any question regarding this part? If there is, please feel free to ask. Please, there is one question from Mr. Manohar. Please show 3D view of design with the mount height equals to 3.5 meter. Sure, Mr. Manohar, I'll show it to you. So if I, okay, I'll show you the difference. Okay, first let me show you in 3D when the mount height is 1 meter. So this is my 3D view when my mount height is 1 meter. So if I change it to 3 meters, change it to 3.5 meters, update it, and now if I show you in 3D, okay, so you can see now my mount height has been increased, so my panels are coming in a completely like they are much higher compared to previous. Okay, Mr. Manohar, with this I think your doubt has been cleared. Okay, what is the difference between mount height and the placing structure of 3 meter? Okay, sir, like I am not able to get your question. What does it mean by placing structure of 3M? Is it placing structure of like 3 cross 1? Okay, okay, sir. I'll show you. I'll show that part to you also. Okay, there is one from Mr. Varun. Please make it a 2 panels instead of 1 panel by row. Okay, sure, sir. Like as Mr. Aditya has said, I'll show you that option by doing it a 3 panel in a single row. So if I go back to 2D, here you can see there is this option table size up, table size wide. So what is table size up means? It will add up the rows 1, 2, 3 like that. And wide means like this. So if I make it as Mr. Varun asked for 2 cross 1, so you'll see it will update and place it at the optimum, like maximum panel which it can do. Okay, Mr. Varun. And next is Mr. Aditya asked for a 3 cross 1 panel. So I'll use that one. And now I'll show you the difference in the heights. If I go with 1 meter, okay, so I'll show you with 1 meter. If I save the design now, if I refresh my solar axis, then you will see there will be some panels which will come in. Okay, so you can see these panels are coming in red. Why? Because these panels are still at a height of 1 meter. If I show it to you in 3D, so you can see that these panels are lower than this mounting. So if I increase my mount height now, if I increase this now, and once again, if I refresh my solar axis, so we'll see these panels will come in green. All the panels are coming in green. If I show it to in 3D, what my mount height is doing is it will increase this end of the panel, which is the lower end. It will increase the height of that end. So if I give it as 1 meter, this end will be at 1 meter from the rooftop. So if you do a 3x1 or a 2x1, even if a 5x1, it will obviously have some differences. Okay, so we have some questions here. How can we proceed designing if we predetermined fixed capacity, suppose 200 kilowatt, irrespective of roof size, which is somehow large roof, but we only need 200 kilowatt plant design. Okay, Mr. Indradev, I'd answer your question. That is, as I have shown you. Let me just revert this back to a 1x1 size and update it. Okay, so what we can do is save this design, refresh my solar access once. So we'll know which panels are performing bad and which panels are performing good. Okay, so in this case, there was this, right? Okay. So like Mr. Indradev, your question was for 200 kilowatt. For this particular rooftop, I'll show you. We can place a maximum panels which are giving me a size of 148. But let's say I want only a 100 kilowatt system on this roof. So I'll show you for that case. Similar, we can do it for 200 kilowatt also if the roof surface area is bigger. So right now we can see these panels are not performing good. So we can easily remove these panels. So for that, if I go to the sub array part, we have this option here, optimize. If I click on optimize, then I have there is sub array size. Okay, let's say right now the maximum it can go up to is 148. Let's say I want only 100. I'll just enter 100 here, press enter. It will select the best panels which can make a system of 100 kilowatt. Okay, so like this you can do that. Then how can we give tilt to industrial sets? Yes, sir, I'll be coming to that option of the industrial set. First, I will take this RCC roof, then we'll go to the industrial set. Please wait for some time. Sketch along with the dimensions. Okay, so we have a doubt here. Do we have option for structural design outsketch along with dimensions? So, ma'am, what we are giving here is this structural designs are only for visualization. These structures are only for visualization. So, if you want their dimensions and their analysis, you have to go to a civil engineer, because in structures there is a lot of things to be considered, like there will be roof strength, then your material strength, everything. So I think that will come under part of a civil engineer. So so our software is only mainly for the PV system design and PV generation. So we have given the structure only for the visualization part. Okay, can we use elevated structure and show the design? Yes, Mr. Manohar, that is the same as the tilt structure. I'll show you how we can do that. But before that, on the RCC roof, I'll show you one more feature. So let's say right now I want to place some panels over this area because we have a obstacle here, so we are not able to place the panels here. So let's say I want to place the panels on top of it. So what I can do is, here we have this option. We have to uncheck the placeable and just check the ignored button. If I update it now and then my sub array, if I reset my sub array, we can see it will place panels on this particular area also. So like this, you can use this feature if, let's say, if there is some tank. Let me create one tank on this bounty. So there, say, here is this tank. If I mark it as ignored and unplaceable, if I update it, now if I will place, so it will place my panels even if there is tank. So it will not like it will place it according to the position of tank and then place it there. So we can have like that. So we can increase the number of panels we can place like that. So if you have any doubt in this ignored option, then you can please go ahead and ask. Or if there are no doubts, then I'll go with the shed part or the tilted parts, the tilted roofs. What about electrical side like AC and DC cabling along with the different size of cable recommendation and current carrying capacity? Okay, ma'am. For the AC and DC cabling, I'll show that to you. Like after we place inverter, we have that option also. I'll show that to you after this. Okay, so I think there are no doubts on this ignored option. Okay. I will just optimize this array. Close this. Okay. So next, yes, sure, Mr. Varun. I'll show that ignore option to you again. So what is this ignore option is like here. If I show you in 3D. So here you can see there are two tanks on this mounting. So if I place panels here using the fill face option, you can see it is ignoring this particular area where there are tanks. Okay. So let's say I want to place panels over these tanks also on top of these tanks. So what I can do is I can mark them ignored, update it. Similar for this one, I'll mark it ignore. And then if I reset my sub array, you can see it will place these over these. If I show it to in 3D. So like this, you can see it will place the tanks. It will place the panels on top of tanks also because the tank height is lower than your panel height. Or if let's say there is some case this tank is of 1.2 meters, so we can see now it is crossing it. So for that we need to make sure, because right now it is ignored, the panel will just ignore this and place. So for that part we need to make sure we also increase our mount height. If I show it to you before increasing my mount height, it will cut the tank like this. So now what I need to do is I need to make sure that my panel's mount height is greater than my tank's height. And then replace tanks like panels like this. Okay, Mr. Varun, are you clear with this option now? Elevated module structure on RCC roof. Okay, sir, I am not able to get your question. Like elevated module structure, which kind of structure are you talking about? Superstructure. Okay, sir. Okay, sir. You want to say like the lower height of second row will be equal to the higher height of the first row. Like that is structure you want. Okay, sir. So to create that, what we need to do is, sir, then we'll need to place our tables in a row mode. So let me do that. Okay. Let me just delete this subarray. Okay. Or I'll just simply show you here how we can do that. So we can't use fill face, because in fill face, if I increase the mount height of any one panel, it will increase for the complete subarray. So for that, I can do is I can use add table mode. Let's say I'll make one row here. Okay, so I made this one row. I'll complete it. It will create one sub array here. Then I need to create one more sub array behind this, a row. So it will automatically consider the row spacing. You don't have to worry about that. I'll create another row behind that. Okay, so like this, I created another row. So now these two are different subarrays. So if I change the mount height of this subarray, this subarray will not be affected. Now to check the mount height of my subarrays, what I can do is, here you can see there are three XYG axes here. So I can check what is the top height of my this panel. If I move my cursor to the top of this panel, I can see that my Z axis is coming as 12.157. Okay. And this rooftop was 10.05. So if it is 12 meter, so what I can say, if it is 12.16 and this one is 10.5, so we can say that it is 1.66 meter above this mounting. So I can increase the height of my this subarray to 1.66. Then I need to update it. If I show it to in 3D, now you can see this will be like this, and their space will be like this. Okay, Mr. Manohar, I think this was your doubt. Okay, there is one question in the sum simulation for shadow analysis. Do we consider summer and winter directly? Like winters will have longer shadow. Okay, ma'am, for that part in this sun simulation, we are doing it with the for each and every day with the data from weather data, like from metronome weather data or whichever weather data you want to import to the system. So it will consider based on each particular day. So yeah, it will take in consider about summer timing and winter timings. And you can see if I show that to you, let me once again show it. If I do the sun simulation, let me go to 3D. Okay, so let's say I want to check it for 3 p.m. So if I show it to you for 3 p.m. each day, you can see that even at 3 p.m. at each day, the shadow is going differently. So here you can see the date is changing as well as the shadow. So as we are coming till the December part, we can just see at 3 p.m. the shadow is longer. And when we goes to the summer part, you can see now the shadow is decreasing. So I think now this doubt is clear. We have elevated mounting rooftop projects in multiple row and multiple column in one roof without gap, if is it possible? Okay, Mr. Sundaraja, we can do one thing. We can have a separate meeting on this topic, like because right now we are on the optimization part, so we can have separate meeting on this topic. You can just leave your contact information in the chat part, and we'll reach you out for that part, or you can just simply give us a message on intercom. You can do that part. Okay. Okay, so next I'll go with the tilted roofs or the shed type structure. For that, I need to go to 2D. So here we can see there is this shed. So I'll create this shed first. To create this shed, I'll just trace the boundaries of this shed. Then what we need to do is we need to give it the direction where the lower side is. So from here we can see the lower side will be in west south direction, southwest direction. This side will be lower, this side will be higher. So in the azimuth we have to select this southwest direction. Then what we need to do is we need to give the base height, which is the height for this lower side. Let me give it as 10 meters. Then next is what is the tilt of this shed. So let me give it as 8 degrees. As in India, for the industrial shed, we are having tilt that is from 6 to 9 degrees. So I'll give it as 8 degree and I'll update it. So now if I show it to in 3D, this is how your shed will be looking like. Okay. You can see there is a difference in height of this side and this side. You can see now. Okay. Okay, there was one question from Rauf Raja, like how can we give tilt to industrial set? So this is like we can give a tilt to industrial set like this. The next is like there will be some vents on the set. So let me create these vents. I'll create these air vents using the cylinder tool. Mark them as non-placeable. Update it. So next what I can see there are a lot more air vents on this shed. So I'll just use the copy paste feature. I'll use Control C, Control V, and then I can do is I can use the repeat command. To use repeat command, I have to press R, and if I press R, you can see that this repeat count is enabled. Just I now need to enter the amount of copies which I want. Here I want 4 copies, so I'll enter 4. So you can see I will have 4 more copies, and then I just need to place them. Okay, so if I show it to in 3D, this is how my half shed will look like. Next, what we need to do is to create a complete industrial set. We need to make the other half of this set. So either I can do it by creating the polygon again, giving it tilt again, everything, or simply I can just copy paste it and use the mirror feature by pressing M on my keypad. So now I'll select one side across which I want to mirror this. I'll press and I'll just place it. Just so if I now show it to in 3D, this is how my shed will look like. You can see there is tilt to both side of the sets. So like this is how we can create the shed like structures or industrial sheds. So next what we need to do is we need to place some safety lines on this shed. For this we have this feature here, safety line. We'll place safety lines for both the sets. So if I show you in 3D, this is how my safety line will look like. Next is for placing now what we comes is placing panels on this shed. So if I go use my fill face option, okay, here we can see the template type. My software has automatically considered is a flush mount. Why? Because this is a tilted roof. But for this RCC roof, you can see it was fixed mount. So if I show you show you the difference. So if you have a tilted roof, your software will automatically consider it to as a place the panels in a flush mount template. Okay, size fill face here. Okay. So like this, I have placed all my panels. Now what I will do is I will once again refresh my solar access to check the efficiency of these panels, the performance of these panels, because these panels were facing true south, but these panels are facing east and west. So obviously these panels will have some losses, and similar thing we can see here. So now what we can do in this part, in this cases, I can go to the sub array. I just need to change my fixed mount, flush mount to fixed mount, and then I will decrease my mount height and increase the row spacing and update this. So like this, we can do the reverse mounting on my shed type structures. So if I save it and once again show you the solar axis, you'll be easily able to notice the difference. Okay, Mr. Aditya, what we mean by flush mount is, okay, let me show you. These are the template style. Let me show you to in 3D. So fixed mount is like you can fix it at any particular tilt, whichever you want. Okay. The flush mount will be, it is mostly used on the shed type structure where the roof is already having a tilt. So we just place the panels on the roof. We don't give a structure below this. So we just place it on the roof to create a flush mount type template. So this is what we call flush mount. As you can see the difference in this fixed mount and this flush mount. Okay. Next here we can see that here once again we have changed this part to a fixed mount part. Like so for this, because this is a tilted roof, so structure will not show up here. So we can see that now when I reverse tilt the panels on this shed, we can see the difference. Like before these were coming in red color, now they are coming in green or yellow. So before they were in this part where the efficiency is only 0.7, 0.76 or 76%. But now we can see that it is coming in 97, or the minimum is going till 95. So like this, we can optimize our panels on top of our shed part. If anyone is having any question on this part for the shed part, the mounting part, they can please go ahead and ask. Please, if you have any question, please ask them. Please post them in the Q&A session or the chat session. Okay. There is one question: how to add walkways? What is the criteria for placing safety lines? Okay. So, Mr. Aditya, what is safety line is there for? Like before placing the panels, if an installer is going to place the panels on top of a tilted roof, so for their safety purpose, they will first place a safety line where they can, you say, where they can rope themselves. So if they slip from the shed, they will not directly go down. They will not be pushed from the shed. So there is a safety for them. So they can rope them to this safety line. Yes, sir. Next is from DS Enterprise we have, that is how to add walkways. Sure, sir. I'll show you that. Let me save this design and hide the solar access. So to add walkways, here we have the option walkway. Okay. Let's say you want to add a walkway like this here. So if I add one here, you just simply need to make a walkway, and you can see that the panels has been adjusted according to this walkway automatically. Next, you have the properties of walkways here, like its height, its width. Let's say I want to increase its width to 1 meter, I can do that. If I update it, you will see panels will automatically adjust. And if I show it to in 3D, this is how your walkway will look like. Okay, so regarding the safety line, it will be placed there permanently, because it is not like that once you place the panels, there will be no need for safety line. Once you place the panels, you need to clean them. there is maintenance part. So for that purpose, it will be permanently there, because when someone is going to clean them or for the maintenance part, they will need to rope themselves to this safety line. Okay, sir. For walkways, it is like the walking purpose, the walking area you want. So you can place that according to that requirement. If the client is asking for walkways, or if the installer is think, if as an installer you want a place for walking there, when you want to do the maintenance, okay, like that. So you can place walkways in between. Okay, we have this question from Ralph Raja. Can you please explain about using shortcuts commands? So, okay, sir, for shortcut commands in the Solar Labs, we have few shortcut commands. That is, if you go to models, for polygon, either you can select from here or just simply press P from your keyboard. So if you press P, you will have the polygon tool activated. Then similar for cylinder, you have to press C. Walkways, you have to press W. For safety line, you have to select the safety line from here, because if you press S, you will have the add sub array enabled, not the safety line. Next, for handrails, you can simply press H, and for trees, you can simply press T. So these are the shortcuts you can use. And if you want other shortcuts, they are in this help documentation. You can check all the shortcuts from here. Okay. Can we insert any component or drawing that drawn from another software? No, Mr. Kripal, we are not like we cannot insert any kind of drawings in this. So any kind of import is not there in the Solar Labs. You can only export this from this part. You can export for PVSys, you can export for Google SketchUp, but there is no option for importing any kind of drawings from another software. What is the SI command for copy? Okay, so okay, so for the copy, like just like any other software or any other program in your laptop or your PC, you just need to simply press Control C and Control V to copy and paste. And if when you press Control C and Control V, after pressing Control V, you will have the copy of that object, and you can just simply place it wherever you want. Are there any other questions? How to make a joint structure on two or more different height roof if structure height more than all the roof? Okay, sir. So you want a joint structure. Okay, let's say I'll do this part here. Let's say you want a structure which is like coming from here, and you want it as a joint structure from here to here. So first, what I need to do is I'll use, this is a 3.5 meter. So I will increase this subarray height to 4.5, update it and reset it to get all the panels. Okay, so next, what you can do is, I have this component, you have this add table mode here. You just then have to add the tables in line with this. So we need to check. So this says at 1 meter, and these were at 4.5. This is 3.5 plus 1, 4.5. So all will have same height. If I show it in 3D. So this is how your structure will be there. For joint structure, you can use it like that. Can I export a Solar Lab file to SketchUp model? Yeah, sure, sir. You can export the Solar Labs file to Google SketchUp. Go back to 2D. Then here you have this export feature. You can export your for SketchUp. So you will get a file. You will get a file downloaded to your PC, which you can import to your SketchUp. And similar is there for PVSys, and for SLD part, if you want to do that in AutoCAD, you can download a SLD for AutoCAD from. Suppose in one building there are three parts on different heights. How can I do that? Okay, Mr. Aditya, as I have shown you, let me once again show it to you. I'll create one polygon here. So if I show it to in 3D, so like this, we have three different heights here. One is for this roof, second is mountain, third is this mountain on top of this mountain. So if I need to place panels here, what I can do is back to 2D. Yeah, if I add table, so I can see this rooftop is highlighting when I'm placing a panel. This means this panel will be on top of this rooftop. So I'll place one, two, three panels here, and next panel is on top of this rooftop. So I'll make a different sub array for that. So for this sub array, here we are having a height of 10.5, and it was 7.5. So it is for 1 meter only. For this sub array, I need to change the height to 2.5. Take it. Now if I show it to in 3D, so now you can see there is this structure, you can place it like this. You placed panel in same panel. No, sir, I have used different subarrays. Let me show that to you. You can see if I click on this subarray, this is for these three panels. If I go to this subarray, this is for these three panels. And if I go to this subarray, this is when I used creating the fill face, that is this one. Yeah, Mr. From Mr. Cubicle, like I have already shown you, you can simply export for your SketchUp here and then can import it to your SketchUp part. So if you want that part, I can share a video with you regarding that part. Please share your email ID with us, so I'll share that video with you. Or you can just simply ask me over the intercom. Here I will reply with the video how you can import. No, Mr. Krupal, right now we are not having this cable sizing calculation. So we are working on this feature. Maybe it will come up in some time. So we will have that in that particular then. But right now we don't have the cable sizing calculation. And for this, like for which square cable you want to use, That depends on installer to installer and location to location, like which cable you want to use. You want to go with the copper cable, you want to go with the aluminum cable, you want to go with 4 mm, you want to go with 2 mm. So it will depend from installer to installer. So I think for the that length sizing calculation, it is not in the software for right now. Sure, sir, I'll share the video with you. So I think these were all the questions regarding the tilted roof. Next, I'll go on the electrical side where I can place the. Okay, so before doing that, I'll just go back to my previous model. Next is, let's say I don't want these single panels because installer tends to place panels in particular tables. So I don't want these single panels. For that, we have this feature here, pan delete mode. I can select all the single panels which I don't want here. Will delete them. Let's say now I want to add a panel here. I can just simply copy paste this panel, place it here. Can we extend some 2 3 panels from out of building in case of smaller roof area? Okay, you want the panels to be in a like hanging position. So for that, you have to create a table. It will be for a small part only, not for a very bigger part. Okay. So like this, you can make a hanging table. Okay. Please share your all your doubts in the question answer session. So we'll be able to take these. If you have any doubts, please share them with us. Okay, so then next I'll go to the AC part. That is how we can place inverters. So to place inverter, I need to select the inverter according to my load ratio. Right, like right now we can see that my AC size is 0 and my load ratio is infinity. So based on my DC size, where I am having a DC size of 304 kilowatt. So at peak only it can work at 304 kilowatt. So obviously these panels will not work at their peak for 365 days throughout the year. So mostly we do the overloading. So for here, I'll select some inverters. Let's say I want to place some 60 kilowatt inverters. So I can check all the information about my inverters here, like their number of MPPTs input per MPPT. Let's say I'll place this inverter. But completed. So like now we can see my AC size has been updated to 300 kilowatt as I have placed 5 inverter of 60 kilowatt, and then my load ratio is 1.02. So like this, you can place inverters. If you save it, then we have an option here, that is AC/DB and AC cable. Let's say I'm placing an AC/DB here. and then I add the AC cable from my AC to this ACDB. So like this you can add, but this will be only for the visualization purpose. So you will not have any feature for this like the length calculation or other thing. It will be just a visualization. Let's say my inverter, this inverter is placed here and this ACDB is placed here. Now I want to just create a AC cable from this inverter. This ACDB. Just a second, it created it down. Right. Okay. Now my inverter is placed on this mountie. Let's say I want to make a AC cable. Like this, you will have an AC cable. This is only for the visualization part, so you will not be having it. Can we write any note on design screen? Yes, sure, we have that feature also. Here you can see there is this text box. Let's say I want to name this roof as roof 1. I can create a text box here. Then I can write 1. Then we have the color option here. We can set the color. We can set its size. So like this. Then we have the font, whichever you want. Then if you want it bold, it italic. Then for the shape, so like this, you can do that. So I'll just cancel it. I don't like this. You can do that part. So next is how we can do the DC stringing. For DC stringing, if you go click on the inverter, here we have the option MPPTs. So now I can see all the MPPTs in my inverter. So if I select any one MPPT, I can see the maximum and minimum range for my string. For a single string, it is giving me that you can minimum go with 7 panels or maximum with 23 for the best results. Then we have here is maximum string count, like how many maximum string this particular MPPT can have. Then the suggested string count, how many string you should attach. And then here we have the option for add string. So let's see, now I want to add string to this. So I will use add string and then start bringing it. So you can see when I go to 7, from 6 to 7, as my system suggested, I will go with 7 to 23. So it will go green. But when I go above 23, once again it will go red. So let's say I want to add 23 strings. Then for second string, I have option there. I will add a second string. But now it will only come up in green as when it will have exactly 23. If I go above 23, go below 23, it will be red. So like this, you can add string. So for same MPPT, you if you are adding two string, if you are adding three string, you need to make sure all the strings have same number of panels. But when you are adding string, there is one option, one feature which I'll tell you. If I save my design be saved. So this calculate generation button is enabled. So if I add string, only those panels which are having string will be taken in consideration while using the calculating the generation. All other panels will be not taken in consideration. So you need to make sure all the panels are there in the string. So if I calculate generation, okay, so Mrs. Suman, this was how we can do the AC and DC cabling, but these are like for the size of cable recommendation and current carrying capacity. As installer, you have to make sure because every installer will go with different parts. Like you want to go with a 4 mm cable, you want to go with a 6 mm cable. So it depends on installer to installer. Then the size of cable and the material of cable, it all depends on the installer. So when I do the calculate generation, we can see my generation is calculated, and here we comes up with my annual generation, my specific generation, my performance ratio. So like this will come up. So if you want, if you have any other question, please feel free to ask. I think this was most of the part, like how we can optimize our design, how we can use the ignore feature to place panels at difficult situations where there is some obstacle, then how we can optimize panels on our tilted roof. So this was the about optimization part. If you have any doubt, please feel free to ask. If you don't have any doubt, you are free to leave. How to measure distance in model? Yes, sir, to measure the distance in model, we have this feature here, that is dimension tool. If you use this dimension tool, let's say I want to measure the distance of this mountain from this wall. So we can see it is 4.976. Let's say I know it is exactly 5. I just need to select it, enter 5, press enter. It will move it according to exactly make it at 5. Let's say if I know it is 4.5, not 5, I'll enter 4.5. You can see it moved the mounting with this distance. So like this, you can measure distance. You can do that between two tables, between two panels. You can do this. Let's say I want to check the distance between these two panels. You can see it is 1.16. So, but if you change this, it will move any one panel only because it is a 1 cross 1 table. So it will move a single panel. But let's say if you are having two tables, so if there are these two tables, and now You want it to be at 3 meters. You'll do it like this. What is the best way for measuring DC and AC cable? Okay, so for measuring DC and AC cable, like right now, we are not having this feature to measure the DC and AC cable. And regarding the practical sides, I think I would be knowing less about this rather than you, because you are doing that on practical sites. So I think it would be best. I'm not the best person to answer this question, like the measuring of DC and AC cables. If anyone else is having any doubt, please feel free to ask. Okay, then if no one is having any doubts, I will close this session in 5 more minutes if there are no other doubts. Uh, yes. Like, I don't know your name, but Mr. Achin, I will make sure to share this video with you. And if you don't get it, so please, you can also see you have this icon on there. You can easily start a new conversation. You can send us a message from here. Just like ask for the video, and there you can have the video link. So you'll be easily able to get that. Or just a second, I'll think I will share the video with you. Okay, Mr. Kubel, please check the answer for your question. I have sent a link. You can check this article for how to export the SketchUp file also. Okay, so I have did that here. And still, if you don't get that part, please send us a message from here, and we'll once again show you how to do the SketchUp export. Okay, Mr. Varun, I'm just sending you the message. Okay, I'll be sending this to all. So in the chat box, please check the link, and you can simply check this article. You will be able to see that. Please explain inventory and pricing part. So, Mr. Aditya, regarding the pricing part, uh, you can share your details, and our sales team will contact you regarding the pricing part. And for the inventory part, so I'll show you here. If you see in the sub array, In the panel selection, you can see there is this inventory. There is complete inventory. You can select any panel, any make for any size, and you can just simply do that. This is our inventory. Second is the inventory for inverters. So in inverter, if you go, you can see this is our inventory. So you can just search any inverter and make. So you can easily search for these parts. No, sir, you cannot add any new panel or new inverter to the inventory by yourself. If you want to do that, you simply have to just send us a message from here. You can attach the PDF file, the data sheet of your inverter in PDF format from here, and we'll do that. Because it is a the PVSys, there is this option to add panels and inverters according to your choice. That is because that is a software where you only have access to that for yourself. But here, this software, the TSL, is a cloud based software. So if you make any mistake in adding the panels and someone else use that panel while doing the designing, his whole generation will come up wrong. So we are not giving that feature to you to add it according to your choice. You can send us the panel data sheet, you can send us the inverter data sheet. We will update in some time, and we'll let you know that your panel has been updated. Then you can use it. Yes, sir. For the plan and pricing, please share your contact details so our sales team can contact you, because they will give you all the plans and pricing. I don't exactly know about all the plans, so they will be more able to explain you rather than me. Please share your details, like, so that we can so that the sales team can contact you. Okay, you are asking, I add in Solar Labs the plan and pricing. Okay, there is a pricing part in Solar Labs where you can add the pricing. So if I save this design, I go to this design summary page. I'll come back here. Let it update the design summary page, because previously everything was zero. Now we have created the design, so it will update everything here. You can see it will update the generation analysis also. When I go to this project summary page, you can see here that there we have the option for client requirements. What is the consumption of client? So for financial analysis, we have there here. We have option, both option, net metering, gross metering. If I your state, whichever type of metering is there in your state, you can go with that. Then you have to enter the average monthly unit consumption. Let's say my client is consuming 60,000 monthly. I'll enter that. Then the price per unit, average price, let's say it is 8, as it is in Delhi, in India. Then tariff acceleration, because we'll be doing this financial analysis for 25 years, so we'll give tariff acceleration. Let's say it is a 2%, and we confirm it. Then once again, I'll go to this design summary page. Here you can see there is a pricing option. If I add price, there is this price, how much you want to quote in rupees per kilowatt or in particular rupees. Let's say I quote my customer 25,000 rupees per kilowatt. There is a government tax of 8.9%. Then there is this expected life for which I want to do the financial analysis, 25 years, not giving any discount. If there is any subsidy from your state, you can provide that. If you are charging any maintenance cost, you can provide that. Then if you are for accelerated depreciation, if you want to enter, you can give that here. Then you just simply need to confirm it. You can see here it will come up, instrument, cash, price, how much you quoted, then his return on investment, his internal return rate, his least cost of investment, then his payback period, his tax, everything will come up. Okay, so next is, let me show you how we can download report based on all these parts. Here we have the feature for download report. When I go and click on Download report. Here you can see this reports default page will come up. So it will show us all the pages which are there in our report. So for this particular one, I'll show you each and every page. If I confirm it, it will download, it will generate the report and download it. So it will take some time. I will share another previous report with you. So this is the report, how your report will come up when you create a design. Your project name will come up here. Your DC size will come up. Then your let longs for the project. If you have project address entered, it will come up here. Then here your client details will come up. His client, his details, his contact number, his email ID, everything. Then we have the Solar Labs logo on the left hand side, and on the right hand side, your logo will be there and your company information will be there. Then on about us page, you will have your company logo and whatever you want to write up about your company, it will come up here. Then we have a system metrics page where you can see the annual production, the performance ratio of your system. You can see the specific generation of your system, everything you can see. Then the DC size, the AC size, the load ratio, which weather data set we are using. Then next is the estimated savings page. Like for the next 25 years, he can save this much money. Whatever he's investing, he'll get back that money in this much time. Then his internal rate of return is this much because it is 48%, so he'll only get it in 2 years. If it is less, payback period is longer. Like that, what is the price you quoted to him? If there was any tax percentage, for this report, it was zero. Then the least cost of then there is this expected lifetime for which we are doing this savings analysis. In this, you can see similar thing is given in this graph format. So for the 2 years, for first 2 years, it is his payback period. No savings are there. So from the third years onwards, we can see each year he will save, and each year his saving will add up and will add up to a certain amount. Then we have the components page, on which all the components will come up, how many models were there, which everything will come up here. Then we have this monthly production page. For first year, you can see for each month how much this system is producing. Then the monthly savings page is there for first year. For each month, how much money you can save. Then we have this global data where we have the data for direct irradiance. In the monthly table, we have this data for direct irradiance, diffused irradiance, then effective irradiance. What our DC will be producing based on this effective irradiance, what we'll get in AC as an output, then what is a specific generation of our system, what is the performance ratio of my system for each particular month, and then at last for the complete year. Then we have field segments like how many subarrays I have created, in which orientation they were, what was their tilt, what was their azimuth, then row spacing for each subarray, what was there, the frame size, how many modules were in each subarray, what is the DC size of that subarray. Each thing will come up. Next page will be shadow analysis. For June 21, 9 to 5, the longest shadow day. The second longest shadow day is December 21, 9 to 5. Both shadow analysis are there. Then we have a conclusion here. That is, panels are shadow free for 99.14% of solar time throughout the year. That means these panels will not have any shading losses for 99.14% of time, or you can say for 0.86% of time throughout the year, there will be shadow losses on these panels, which we have placed for this particular orientation. Then next we have the heat map and the solar access page. Then we have the losses page. For white, we are here is irradiance losses. For blue, these are DC losses. For green, you can see these are AC losses. So all the losses will come up on this losses page. Then we have a interesting feature of cost of not going solar. That means there are two graphs, there are two bars for particular 1 year. So for the next 25 year, you can see this data. This white bar is the amount of money your customer will be paying to electricity company if he goes with this solar plant. Then this blue one is the amount of money which he'll be paying if it don't go with this solar plant.
So also we can see that the white bar or the amount of money he's paying to electricity company, if he goes with solar, e- even on 25th year it is less than what he is paying on the first year. So like this, you can make a comparison, you can show to your client. Then we have the impact on environment page to show to your client like how much how is going with an eco-friendly system, because the solar system is a eco-friendly system where you can have a positive or good impact on an environment. Because if you are using the electricity from supply board, they are using the thermal power plants or the reactor plants, so there will be some pollution created from those plants. There will be some carbon dioxide offset or some coal burns. So for that you can show that you can save this much of coal burn, you can have, which will be equivalent to planting this much number of trees. So like this you can show him how he is going towards a green environment, towards a eco-friendly system. Then you will have a thank you page. And next is we have this 3D link here for showing to your customer how his rooftop can will be looking after placing all the panels. If you click on this, click to view 3D, or simply click on this image, you will come up to this particular page in the design studio, and you don't need to have the access, or you don't need to have an account on design studio to log into this page. You can simply, anyone can open it, anyone can check it on their mobile phone easily. So like this you will come up here. Here we have all the four main details for annual production, the system size, then the return on investment, and the payback period. Next is also we have given the feature of sun simulation here, like your client can see the sun pattern on his roof for any particular day throughout the day. He can check it, or for any particular time for each day, how the shadow pattern is changing. So this was the report part. Okay, if you have any question in this thing, and particularly the report part, you can you can ask that. If not, I'll just right now stop sharing my screen. If you have any questions, please ask them. Okay, I think we are not having any other doubts, so I'll just end this session now. Send recordings. Mr. Aditya, okay, sir, this video will be there on our YouTube channel. Please go there and you can check the recording of this video there. Sir, you can simply search the Solar Labs in YouTube and you will come up to the Solar Labs YouTube page. Or we can do one thing, just you can share your ID with me here. I'll send you the recording also. Okay, sir. I'm ending the session now.